Hello friends, in continuation of the educational videos on the S100 series inverter by LS, today we want to talk about the analog outputs of the S100 series inverter. We have already discussed the analog inputs of the S100 series inverter, including the 4 to 20 mA current input and the 0 to 10 volt voltage input. In addition to the analog voltage and current inputs, the S100 series inverter also has an analog voltage and current output. As you can see in this image, the inverter is equipped with a single analog output. Now, you can set this analog output using the DIP switch installed on the inverter to specify whether the analog output is voltage-based 0 to 10 V or current-based 4 to 20 mA. If DIP switch SW3 is set to I/O, it means this I/O terminal functions as a 4 to 20 mA analog output. If it's set to VO, the analog output will be 0 to 10 V. So the I/O and CM terminals, here CM is used for digital inputs, analog inputs, and analog outputs, meaning CM is the common terminal for all of them. Therefore, the terminals related to the analog output on the S100 inverter are AO and CM, and by using DIP switch SW3, we can specify whether this output is current-based, 4 to 20 mA, or voltage-based, 0 to 10 V. However, the settings that need to be configured on the S100 inverter are in parameters OU01 to OU01. Now let's refer to the S100 inverter manual. In the S100 inverter manual, there is a parameter called OU01 named AO1 mode, which is where we need to specify the analog output mode. For example, if we set DIP switch SW3 to voltage mode and want to use the S100 inverter's analog voltage output of 0 to 10 V, we need to configure the inverter and let it know based on what criteria it should provide this 0 to 10 V output. Look, the OU01 parameter, which is the same as AO1 mode if set to 0, will give us 0 to 10 volts based on the output frequency. Exactly, which frequency is this? It's the frequency you set in parameter DR20, which is your maximum frequency. For example, if you set parameter DR20 to 50, the inverter will give us 0 to 10 volts at the output for frequencies from 0 to 50 Hz. That means at 50 Hz it gives us 10 volts and at 0 Hz it gives us 0 volts. And this 0 to 10 V is divided between 0 and the maximum frequency. So the first one was frequency, the second is output current, meaning based on the inverter's output current, it gives us 0 to 10 V. There are other parameters like output voltage, inverter output voltage, DC link, or based on torque. So in the OU01 parameter, you need to specify for this inverter according to which criterion you want the 0 to 10 V to be output. In this example, we want it to be based on the output frequency so that at the maximum frequency set in DR20, it gives us 0 to 10 V. Okay, let's go back to our own parameters. So, in OU0.1, we need to specify according to which parameter this inverter should output is 0 to 10 volts. We want to set it to 0, meaning the frequency that we set in parameter DR20. OU02 is our gain, OU0.3 is our bias, and OU0.5 is a fixed value. For example, if you do not want the 0 to 10 volts to be given based on a certain criterion, or you do not want it to be based on output frequency, and you want the output to always give you 10 volts, you should set the OU01 parameter to constant instead of frequency, meaning a fixed value, and in OU0.5 specify what percentage of this output voltage you want. For example, if you set it to 100%, you will get 10 volts at the output. If you set it to 0%, you will get 0 volts at the output. But pay attention here. What do gain and bias mean? If you set your gain to 100% according to the graph, you will see that you get the full 10 volts at your output. For example, if you set it to 80%, you will see that you get 8 volts. That means you are dividing 0 to 10 volts between 0 to 100%. The output voltage you want should be set based on the gain. If you want 100% of the output voltage, you should set it to 100%. If you want 80%, you should set it to 80%. 0 to 10 volts becomes 0 to 100%. But what is bias? Sometimes you want it to start from 2 volts, meaning that before 2 volts it's 0, and from 2 volts it starts giving you the analog output voltage. In this case, you need to set it based on the OUSO1 parameter, which is the bias here. As you can see, my bias here is 20%, so it starts from 2 volts, meaning it begins at 2 volts. My gain is also at 100%, so it starts from 2 volts up to 10. So the bias determines the lower value, specifying from which voltage it should start, and the gain sets the maximum, asking what percentage of the maximum voltage you want in the analog output. 0 to 10 volts corresponds to 0 to 100%. 10 volts is your 100% and 0 volts is your 0%. Alright, but in the example we want to do in this tutorial video, we want to set our AO0 mode to frequency. So we need to set AO0 to 0. Based on what does it set this? It's based on DR20. What is DR20? The maximum frequency in the sweep is 0 volts, the value you set in DR20. For example, if you set it to 50, this 50 Hz at the output gives you 10 volts. We set our gain to 100, meaning we want the correct 100, and we want our 10 volts at the output. And we set our offset to 0 as well, saying it should start from 0 up to 10. But how does our signal shaping look? And what is the use of the analog output anyway? Look, for example, you have a steady inverter, and next to it, you have an i7 inverter. Now, let's say you don't care much about precision, you just want these two to operate at roughly the same frequency. You set the steady inverter, for example, to 50 Hz. And then you take the analog output from the steady inverter, that is, you connect the A1 and CM terminals, to the analog input of the S7 inverter. So whatever value the steady inverter has, the S7 inverter will also use that same frequency. Or for example, you have a display that only accepts up to 10 volts. Now, on this display, you've set it to show us the RPM or the frequency value of this inverter. You set the analog output of the inverter so that it gives you a value from 0 to 10 volts. That is, we configure its output to range from 0 to 10. Now you connect the AO and CM terminals to your display. For example, on that display, in its scaling, it might say, show me 50 Hz at 10 volts and 0 Hz at 0 volts. Now, based on the voltage that the inverter provides on its analog output to the display will show you the frequency or RPM value. So for wiring as well, you need to use the AO and CM terminals. Let's move on to the device and perform the settings we just discussed and test the analog output capability of the steady inverter together. Okay, as we said, to configure the analog output of the inverter, what is the criterion for this inverter to give us 0 to 10 volts at the output? We said we want to set it based on the maximum frequency, meaning it should give us 0 to 10 volts according to the maximum frequency. First, we go into DR20. We specify the maximum frequency value. Here, my maximum frequency is 50, which was set in DR20. Then I go to OU01. We said that if it's set to 0, it means that it will give us 0 to 10 volts based on the maximum frequency. 10 volts means 50 Hz. At 50 Hz, it gives us 10 volts. And at 0 Hz, it gives us 0 volts. I set it to 0 and confirm it. In this video, we said our gain is 100%, meaning it gives us 100% of the output voltage, which means it gives us 10 volts. Our bias is also 0, meaning it starts from 0 volts up to its maximum, which is 10 volts. Okay, let's go back. Here, I've placed a multimeter to display the DC voltage for me. I've connected it to the AO and CM terminals, set it to DC voltage, and now whatever frequency I give to the inverter, my multimeter should show the DC output voltage at the AO and CM terminals. We said that at 50 Hz, my inverter should give me 10 volts at the output. So for example, if I give 25 Hz to the inverter, it should give me 5 volts at the output. and I start my inverter. Well, as you can see, my multimeter is now showing us 5 volts. If I increase the frequency and set it to 50 Hz, since my maximum frequency is 50 Hz and my analog output range is 0 to 10 volts, at 50 Hz I should have 10 volts at the analog output. So I increase the frequency and set it to 50 Hz, then press OK. You can see that the voltage value at my analog output changes and is set to 10 volts. Now my maximum frequency is 50 Hz, and I've set the inverter to 50 Hz. At 50 Hz, it should give me 10 volts. You can see that my multimeter is showing 10 volts. For example, I'll change the frequency value and set it to 10 volts. At 10 Hz, it should give me 20% of 10 volts at its analog output. You can see that it's giving me 2 volts. So on the analog output of the inverter, we need to set the voltage so that it gives us 0 to 10 volts at the output based on a certain reference. Here, we set the maximum frequency. We set the maximum frequency in parameter dr20 to 50 Hz, meaning at 50 Hz it should give us 10 volts, and at 0 Hz it should give us 0 volts, just as we did in the example. Again, I'll increase the frequency and set it to 50 Hz. At 50 Hz, my multimeter should display 10 volts. You can see that I now have 10 volts at the output, and the terminals I used are the O terminal and the wire.